Design Twitter. Hey everyone, welcome back to another Exponent System Design mock interview. My name's Kevin, and on today's show we have Josefa. We're going to be doing a system design technical interview question, but before we get started, Josefa, do you mind just telling the audience a little bit about yourself?
Sure. Hey everyone, I'm Josefa. I'm an engineering manager at Facebook. Prior to Facebook, I was at PayPal and Wealthfront.
Excellent, thanks for your time today. So we're going to be doing a system design mock interview, and this is what I'd like to ask. Design Twitter.
Okay. All right. So Twitter is a two-sided network. So you have people creating tweets and people consuming tweets. So given that, I'll break up the system diagram into these two halves. So let's start with some of the core requirements that we would want to tackle. The first one being creating a tweet. I think that's fundamental to the system. The second one I would think here is for someone who's following different people, being able to view all the tweets on their timeline. So right, viewing, or you can say generating the timeline for the user. The last thing I would want to kind of look at is being able to follow people and interact with tweets. So in terms of replies or the like symbols. So these are the core requirements we are looking at. In terms of some non-functional requirements, I would say that one thing we need to look at is that Twitter is going to be a read heavy system. So there will be more people reading and viewing the tweets than writing. So we would want to optimize for reads, and the other thing we would want to kind of optimize for is influencers. So basically someone like Lady Gaga or Justin Bieber kind of writing a tweet would we want to make sure that if they create a tweet, it doesn't bring the system down.
Yeah, this makes sense for like a P0, but if we were to make like maybe P1 or P2 requirements or non-functional requirements, what else might you add?
Sure. I think another thing you would want to add over here is high availability over consistency. So by that I mean is that you want the system to be very highly available, versus that if a user created a tweet, you need not necessarily have the tweet available to everyone to consume in real time. There could be a few seconds lag between a person creating a tweet to everyone being able to kind of read and interact with the tweet. And I would say eventually low latency in terms of especially when it comes to generation of the timeline. So those are the few other non-functional requirements that I would look at.
Okay, and if you had more time for requirements, were there any more that you would have besides creating, viewing, and following people?
I think you could look at generate adding more videos, images to tweets, making the tweets more graphically rich. You can look at other things as maybe editing a tweet. I know Twitter doesn't offer that, but that's like one of the most requested features. You could look at retweeting with a comment, without a comment. So those could be the other features that you would want to add on the system.
Cool. Yeah, that sounds good. So let's stick with what you have here, and maybe you can tell me what you think would be included in the MVP that we're going to design today.
Right. So I think in the MVP, I'll look at these three areas where we have creation of the tweet, generation of the timeline, and basically being able to follow people and interacting with the tweet. So I like to kick it off with a simple API construct over here. I think with creation of a tweet, it's like you could have a post with a slash, create slash tweet endpoint, and essentially the idea here is that in this post the body of the post would essentially contain the tweet, right? So over here you could think of it that the text over here is the tweet itself, which kind of you're sending to your server, right? Then the next endpoint you would look at is basically getting all your tweets, right? So you could think of it as slash home or slash get tweets. So basically this is a get request. The response over here would be in a paginated manner. Let's say the first 20 top 20 tweets that come onto your timeline. The other endpoints you would look at is when you want to follow people. So you would say follow, and then you could pass in the user, or maybe if this is a post in the body itself, you pass in the follower ID over here. So this is basically who you want to follow, right? And your user ID kind of is sent as a part of the header. A similar endpoint over here on the tweet one, you could say is that you like a tweet, with another similar one is you respond, you reply to a tweet, right? So over here your body again is the text is your response to the tweet, and of course you need to kind of know what the tweet or the tweet ID is there, right? So that'll kind of tell you which tweet you are responding to. So these are at a high level, like these 4 APIs that you have. Next I'll get into like a high level system overview of what this system actually looks like. So let's start off with creation of a tweet. So basically you have your users over here. With any large system in this, what scale of Twitter is, you tend to have load balancers in the middle, because it's a distributed system geographically. You'll having multiple hundreds if not thousands of servers serving the millions of users, right? So you have load balancers. Now in terms of creating the tweet, you are essentially what you are saying over here is that you are doing a post over here, right? So it's an HTTP post. You are calling this endpoint, right? So there are a bunch of servers over here which you can call your API servers handling these endpoints, right? So basically anything to do with the tweets, whether it's creation, replies, likes, everything to do with the tweets would essentially be handled by these APIs, right? These servers, right? So anything with /tweets would kind of be handled by these servers here.
Now, how would you distribute the load from the load balancers to all the different, like, let's say you have N servers, how would you know which server to send it to?
Right. So I think there are a few systems mechanisms over here. So something as simple as a round robin mechanism could work. You could look at some kind of a consistent hashing system where every server is hash and then you round robin on the hash. You can also distribute this geographically. So let's say I am in the US and I send a post to create a tweet. So the load balancer would route this to any of the US data centers where, let's say, somebody in Asia or somebody in EU is doing a similar action. They would probably get routed to a data center which is close to their geography. So you could kind of choose to do them in one of these n number of ways.
Cool, makes sense.
Cool. Moving on, so basically this would kind of create the tweet and we would have a SQL database over here where all the users tweets are stored, right? So you have your users and you have your tweets, right? So these are your main two entities in terms of the database that you have. The next thing I would want to look at, and I can get into the database details a little later on. The other thing I want to now tackle is the generation of tweets. So if you look at it, one very simple brute force way is that in your database you have your tweets table. For a given user, if they come to the home or they call the gets tweets endpoints, one simple way is that there is a query that scans the entire tweets tables and removes the most top, like if you're looking at chronological order, top 20 tweets or this n number of tweets for this particular user. Though it's simple in implementation, the downside to that is as your tweet table grows over time, these queries will get very expensive and will cause very high latency in terms of getting the timeline. So to keep the latency low in terms of viewing the timeline, and we want to optimize for reads, there has to be some kind of pre-computation that we need to do in terms of the generation of the timeline itself. So what we would do here is that as tweets are coming in, there is correspondingly a timeline generation service. Basically what this service would do is that map all the users and I can optimize this service for generating the timelines for your most frequent user. So let's say your daily active users, right? So you want to kind of generate timeline for your daily or your weekly active users, like users, let's say, who are viewing Twitter once a month or once every 6 months. We maybe do not compute the timelines for them because that'll just be a waste of computational power. So let's say we are optimizing for our daily active users. Whenever a tweet comes in, along with storing it into our database, we are passing this tweet to your timeline generation service. Basically what this timeline generation service is doing, for every user, it's looking at that tweet and saying that does this tweet belong to this user's timeline, right? Because does it belong to one of the people that this user is following? If yes, it adds it to the person's timelines on the top. So it's kind of a stack where it keeps adding the tweets to the top. So this is like your timeline generation. And as I mentioned that we do not do this for all the users. We want to do this for only our most daily active users. Now as one of the things I also mentioned is that if we want to optimize for influencers, the downside to this kind of system is that somebody like Lady Gaga, who probably has 50-60 million followers, if she does a tweet, you are essentially recalculating the timeline for 50 million people for that one tweet, which computationally is very heavy and very redundant in nature. So basically what you do is, for these set of influencers who have this high bar of users, you don't do the timeline, you don't update the timeline of those people over there. But if when this is basically requested by a user, so let's say another user over here is requesting the tweet over here, so they're doing the get slash tweets. Basically what the load balancer is doing is it's calling this timeline generation service. Whilst the timeline generation service gets the request out, at runtime it will basically take something from your influencers service and add that data to your response on the fly, right? So while the service is responding back, it will add this data on the fly or at runtime and send out the timeline to the users. So this way you're not populating the timeline for these large set of users for these one-off tweets sent by influencers. The next requirement in terms of non-functional was...
And before you move on to the next one,
Sure.
You've talked about all these different types of users, highly active users, maybe less active users. There's also influencers or celebrities you want to keep in mind. It sounds like there's two ways that you can generate someone's timeline, like a pull or push method. And we can clarify this if you need to, but can you talk to me about whether you'd recommend a pull method or a push method for getting someone's timeline?
Yeah, I think it needs to be an hybrid approach over here. So somebody who's your very daily active user who's visiting your app or the website very frequently, I think a push model for them would be more effective. But someone who's visiting Twitter not so frequently after a long time, I think a pull model for them would be more effective, because pushing content to them when they're not accessing it would not make sense. So we would kind of want to look at analytics data to see which users you would want to push data to, whereas which users would pull data depending on their usage.
Got it. Cool. That makes sense. Yeah, let's move on to the next requirement.
Yeah, so the other requirement over here was around high availability as well. So as I mentioned, a lot of these services over here would be replicated. So you don't have one server, you have multiple servers doing this. And in terms of our database as well, right? You don't have one database, you have multiple instances in some kind of a master slave configuration where these databases can be oops, what happened here? Are duplicated here, right? So basically, as tweets go out, they get kind of duplicated over here. So like these are copies of your master database here. So this kind of makes sure that even if something goes down in one of the data centers or one of the databases, you can have backup copies stored. The last thing I wanted to kind of chat about was around the interaction with the tweets. It follows a very similar process where essentially the users are sending a post on the tweet like, or slash tweet id slash reply endpoints, and essentially the idea here is that along with the payload, they get forwarded to the load balancers and kind of get handled by the API servers over here. So this follows the same mechanism as that of of the regular tweet. And one important consideration here that we are accounting in the use cases, that the tweets are just pure text. We've not accounted for use cases where the tweets could be an image or a video. We would kind of need to have a separate kind of a storage to store those images and videos, and then push them onto some kind of CDN for faster access.
Got it. Yep, that makes sense. Let's say that there's a scenario where the PM comes to you and says, hey, we have an 80-20 scenario here where 80% of the users are interacting with 20% of the tweets. Is there anything that you would change with the system design here?
Yeah, so I think what you would want to do is maybe in your timeline generation service, the initial assumption is that we would arrange the tweets in a chronological order. So you would want to tweak that algorithm where you're not only looking at the chronological order, but you are also looking at the interaction on the tweet itself. So you kind of have a weighted system in which your timeline is getting generated. So the tweets that have more higher interaction, higher engagement automatically bubble up to the top of the user's timeline.
Cool. And how about in terms of like storage or caching?
For the tweets itself?
Yeah, let's say that there's like a very small subset of tweets, but it's very popular, it's accessed very often. Is there anything that you would change in the, and you don't have to draw just for the sake of time, but maybe just verbally tell me what you changed.
I think maybe those tweets most likely would be some viral tweets or belonging to some influencers. So you would want to probably in your service over here cache those tweets and then inject them into the user's timelines at runtime again. So I think that's something what I would look at. Generally, what you're looking at is trying to cache the timeline itself and not per se the individual tweet.
Got it. Cool. Thank you. So this is the conclusion for our mock interview. Just for the sake of time, I know that this is just an MVP, and if we had more time, we can go through the other requirements that you had mentioned earlier. Before we wrap up the video, do you mind telling the audience maybe like one or two tips or maybe any sort of advice that you would give someone who's interviewing for a system design interview?
Sure. I think a couple things here. A system design interview is generally a very open-ended question. There is no wrong answer, there's no right answer. There's a particular approach to solving the problem. As long as you are able to validate or justify why you're making certain decisions, what is the reason behind them, that should be good enough. And also for these kind of systems, you don't necessarily, the expectation is not that you need to in 30 minutes, 45 minutes design something what Twitter or Facebook has designed over course of years. So that's not the goal for these type of questions. The idea here is to kind of gauge how you are able to think. So not getting bogged down in the low level details, but being able to think holistically of at a high level how the system will operate, and not worrying about what the exact right answer for the system is. As long as you are able to justify and quantify your answers, that should be good enough.
Yeah, absolutely. And especially with how vague or ambiguous these questions are, the interviewer wants to see how you can take those and then scope it into something that you can cover within 20-30 minutes or however long the interview is. Thanks, Josefa, for your time, and for the viewer, good luck with your upcoming system design interview.